Hey everyone, how are we doing? We're here to answer questions and review for the final for probably maybe until like 3 p.m. or so. How are we doing we did the course evals. We got it for the classes. So for 320 and 474, we don't do it for 201. I'm so sorry, 201. You have a little bit of trouble with this section. Which section are you looking at? Which section are you looking at? We got I don't think we got the points on the final. I think for 474, we were the only class that got points on the final. So the other classes got like 83, 84%. So excellent work. We got the extra drop. Let me go. I've got the screen blanked, right? Let me go and do that right now. Let me go and do that. So let me go to assignments. I'm in 474 right now. One rule for 474. So let me edit this. Let me go to drop 3. Some scores just got improved for 474. Let me go to 320. Thank you everyone so much for the review. It really helps us. And man, I just still can't believe it's the end of the semester. Can't believe it. Don't believe it. Don't believe it. Drop 3. There we go. Okay, so now we have drop 3 in for all of them. Did the 320 get the extra? They didn't. We didn't get the extra points on the final, but we did get the drop. It's always a stretch goal to get those points on the final. And let me double check because I looked at it. Maybe there was a surge at the end. There might have been a sudden surge. So let me check out. Let me know for certain here. And I can display it so people can see it. And I'm pretty sure we said 95%, right? Let me go. Here it is right here. T invoice, and it should be 95%. Yep. And so no one can say there's shenanigans. No one can be like, Brian made up that we didn't get it. I want everyone to get it. Let me go take a look at it right here. I am pulling it up in the background right here. Do I need to grab my phone? I'm waiting to see if it loads in. It's being really slow at the moment. Let's see what chat's saying. It's just for 320, just for 474. I'm so sorry. I'm so sorry, Tyler. Because in 201, we've never tied it to a bonus. It's completely just loading when I load the page. I'll try to get it loaded up here. We'll check back. Up. Okay, wait. Okay, we're gonna have to go back to the. Oh, my phone's charging. Okay, I will be right back here in 2. I know what I'll just blink myself out of existence. This is what I'll do. I'll just be like, there we go. Be right back, everyone. Be right back. I am back. 2 seconds. Okay, getting headphones in, turning camera back on. Let me log in right here. One moment while I log in. Okay. 2-factor authenticate. Everyone knows 2-factor authenticate by now. Good old 2-factor. 2-factor authenticated. And let's bring up the results right here. Fall 201. No. I think we'll give it to. I think we'll give it to like. Wait. Was that 320 section got it? Okay, wait a minute. Okay, wait. I was wrong. Let me take a look at this. I was wrong on the numbers. So let's take a look. You know what we might do? Maybe we'll give it to all 320. I'll talk to Dr. Gosh, I can't even think, Dr. Emery. So let's hear. I was meeting this office hours. I'm never awake. What's up, Andrew? So good to see you here. Let me show the results in the background right here. I think it just has the course numbers and all that on here. So there we go. Here are the percentages. 82% for the morning section. The afternoon section got 94%. And behind my head, 87% for 474. So I was wrong. I didn't get the numbers right. So, yeah, I think we'll talk to Dr. Emery, and these are pretty good numbers. 201, no. So when you don't offer bonus, you get a very low percent return on it. So very, very low percent return on that right there for 201. I know, and I think we'll say maybe since one class got it, we'll and I'll ask Emery how his sections did on the review. So we'll figure something out. So, because technically it's not 95%. We're one person short. We're technically one person short on the afternoon class. I know, Mohammed. Don't worry. We'll be nice. We might do some sort of curve. We'll probably do a curve to the test or something. We'll probably curve the test instead. So the test is usually a little bit difficult. Yes, Lise Alexandria says the test is usually a little bit difficult. Like, we're not trying to make really, 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 really tough tests, but there's only 2 tests you take in the class. So I think sometimes studying for them or knowing how to do them is a little bit more tricky. It's like you do all the assignments, you get in line with doing the assignments, and then it comes time for the test, and it's like, okay, wait a minute, I've got this one opportunity to make a great grade, and if I don't, it could really hurt my grade. So I think that's why we see sometimes lower test grades, because you have more practice on the assignments than you do on the tests. And MuBot is here. I'm trying to update MuBot. I'm trying to make it one of my goals, I'll say this really quickly. When I do, when I ask questions and a bunch of people answer, I want to just say like give all or something like this. I want to put a command in MuBot and I have to get better at Python scripts for this, because MuBot's programmed via Python. So that's why I want to learn Python too. So I want to put a command in there where it'll look back over the last like maybe 2 minutes of people chatting. Or maybe I could do, when we do functions, like I could do give all and then do like 2 after that. It could look for like give all and 2, and it'll give points to everybody who's spoken over the last 2 minutes. So I could say like, hey, who thinks, blah, 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 and I could do give all 2, and I could give points out really easily. And that way I would just do only points via MuBot. So I could do something like this, where the argument's like everybody who's spoken over the last 2 minutes gets 200 points. And I could just give points like that. I could be like, okay, who's got answers right now? Let's see answers. Okay, boom, 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 boom. And I'm trying to figure out how to program that into MuBot. So that way, it shouldn't be that hard to program, but just everyone who's active in the chat. Also, I'm getting more confirmation that the way you get points, like the way it assigns your active points, is you actually need to talk, I think, every 15 minutes. So yeah, 8. And I want to look more into this. I'm on some Discord servers now, hopefully learning more how to program it. But the more you learn, the more you learn. We do have some we have a lot of 320, a lot of 474. 201's got their test coming up on Friday from, I'm always so afraid to say the times, 12:30 to 3:45. I look at it like every day. I've reminded people, I've said it multiple times. 12:30 starting on Friday to 3:45. A big reminder for 201, if you're here from 201, is that 201's a departmental exam, so it takes priority all over your other exams, as in if you have a conflict, especially if somehow there's an overlapping conflict, which we've heard a few of, 201 takes priority and the other instructors need to move their exam. Also, you're not required to take more than 3 exams. Let's bring that up real quick. A lot of students don't know this, but there is a university policy. So final exams policy, I just saw it. I look this up every day too. I know it because I see it every day. But there is university policy regarding taking final exams. So let's put this on the screen right here. So this is the university policy. I'm going to go smaller because I was bigger when I was there. We go, look at that. That's better. So this is, can I go to the center screen? Sure, it's good enough. This is the university policy on taking final exams right here. And so last non-departmental, here it is. Students are not required to take more than 2 exams on any day. The instructor of the last non-departmental final on that day must reschedule. Now, there is the issue that you need to contact your instructor at least 2 weeks prior to classes ending. Do remember this for the future. Most instructors are pretty forgiving on that part of it, but it is, here's the thing, and this applies to me in some instances. If my class is the last non-departmental final on that day, I have to get it moved. I have to move the exam for that student, and I have to use one of the makeup times, or basically just try to figure out a time with them that works. We are required by the university, when I teach like 320, 474, 475, which I'll be teaching in the future, I'm a non-departmental class. And as a non-departmental class, if I'm the last non-departmental exam, I am required to move the exam. And it just kind of helps things work when, like, I'm supposed to. I mean, if you contact a teacher and they say I'm not moving it and they're the last non-departmental exam, that's a little bit of an issue because that's what they're supposed to do. They're required. That's this university policy up here. So, but then make sure to understand that 201 is a departmental class. And we actually have had to move it in some instances. We've had weird things occur where we've had students have 2 departmental exams at the same time because one was a prereq, because somehow that happened. And we've had the issue where there was 3 departmental exams on one day and we were the last departmental exam. So there were 3 departmental exams and we were the last departmental, so we moved it. So 201 has moved the exam, but we try to stick to this and then we move it when we're the last departmental exam, or there's 2 departmental exams. We usually try to be like, okay, we'll take the hit here. What happens if the other section gets the points and the other doesn't? We can do that if we do the bonus points this way. The only one that's really close is section 3, but I think we might just be nice and give it to everyone. We saw some really, like, we got a good response rate. I'm happy with it. I'm a little bummed on the other one though. What other questions are there? I might just ask questions. What do you want to know? You're welcome, Mohammed. I really appreciate it. I know everyone's working really hard. Man, I feel it this semester. I think we've all felt the strain of this semester. Just like, gosh, I really am proud of the students because, I don't know, we're all dealing with this 2020 world in a different way. Like, we're all dealing with, we've maybe had sick family members. We've had, money issues, or we've had, sadness, depression, just loss of people. It's okay. Enough about that. Oh man, let's put some happy music here, not sad music. Let's put some like Punch Out on. We can't focus on that stuff too much. We got to focus on the good things. What questions are there? Ask questions, or I might start doing the Stats 201 page. Might start doing that in later. You got to focus on the positive. Of course, ask a 201 question. Of course. I'm here to, this is kind of office hours right now. I'm just here to answer questions, talk about the material. We've got a lot of review material posted. Ask away. Ask the questions. I wish I could ask questions on the take home. Just keep working on it. Keep working on it. Don't wait to. Some people have waited till the last minute on take homes, and it's bad. Don't wait. Don't wait. I'll never get my lighting right. Never. It's gonna keep making it worse. I'm gonna try to fix. It's because the lighting might change. Kind of stupid. Can you go over the different conditions? 3 will. Yeah, let's do that. Let's review conditions right here real quick. I'm gonna see if I can change this just a tiny bit here. Maybe that's good. Gamma, and there we go. Maybe that's good. Brightness, sure. Wine, no, it's too bright. Too dark. There we go. Saturation. I change this every day, I think. Every day I start a stream. Let's bring the opacity down. I'll just look like that all stream. Hue shift. There's so many settings. There's too many settings. Is there a schedule for office hours this week somewhere? I've just been kind of doing them when I can. I've been working on exams in the background, basically making sure everything's okay. There's been a lot of emails, so I've been trying to make sure everyone gets emailed super quickly, because definitely things have come up and we've had to reschedule stuff and get things worked out. So I've kind of just been hopping. Well, this is the first time I've hopped on, and just kind of I'm going to answer questions. I'll probably hop on again tomorrow and just answer questions for people and kind of help out. That's my goal. And let's start by going over the conditions right here, and let's do it. Let's hop to the main screen here. So here we are with the conditions. So what different kinds of tests? Is our exam graded as soon as we submit it? Yep, for 201, the exam will be graded as soon as you submit the exam. You submit the 201 exam, your grade comes in. I don't think you can see what you got wrong yet, because we're making sure everything, like all the students take it. We don't want you to take it and then like send someone the answers. But you should be able to see your grade, not the questions you got wrong, as soon as you take the 201 exam. As soon as you take the 201 exam. What do we have for the tests? Horrible question. What tests do we have? What test do we have for this? What kind of test do we have? And let's go right here. Let's insert. I'm counting. Is exam 3 normally curved? We don't usually curve it. Could. Is there any videos that go over the topic sheet? Are you saying the formula sheet? We can do the formula sheet. I don't think I have one of the formula sheet yet, but we can do that next. So what kind of tests do we have, Tower? Yep. What kind of test do we have? We can do the formula sheet next. That is definitely something we should do. I'm counting them up. Is 474 exam immediately graded? It'll be immediately graded and you won't see the answers to. Good question there, Colton. I know the practice exam closed yesterday, but is there any way you could open up for us to see the questions again to go over practice? It is reopened, but don't read. I think you can see your attempts, but don't retake it or you will lower your grade. Don't retake it or you will lower your grade. The exam 3 topics, not the formula sheet. Oh, the topics? Yeah, which one do you want to go over? Which chapter? Because I think it's got a lot of topics. Oh no, they're talking about 320 Rocky Top. They're talking about 320 Rocky Top. So they're talking about 320, not 201. Don't worry. Let's write these down right here. Charlie gave us all the exams. Well, we have a 1 sample t-test, 2 sample t-test, and we have a 1 proportion. So let's write these down here. I think it's better if I write them. So here's what we have. We have 1 proportion. We have 1 sample t, 2 sample t, and we have chi-squared. Is this making sense to everybody right here? We have these tests right here. These are the tests that we have. And let's zoom in on a little bit. How is everyone looking with these right here? We have the 1 proportion, the 1 sample t, the 2 sample t, and the chi-squared. Oh, good. Right. I was like, no, Rocky Top, no. So, yeah, I know. We might need to change that. That way those tabs are not clickable. So this is categorical. This is quantitative. This is quantitative categorical. And this is categorical categorical. What's the only combination we're missing right here? What is the only combination we're missing? We can analyze categorical data. We can analyze quantitative data. We can, so yep. And what would be QQ? Everyone knows QQ. That's the one you should be like, QQ, straight enough, no outliers. It's the only one we haven't talked about on this screen. And this kind of helps with understanding what to use and when. Regression, exactly. So these are the different tests. And so you should be able to come up, like, go ahead and tell me I'm testing this and this, Brian. Or just say I'm testing this. So say, Brian, I am testing this and this, or Brian, I am testing this. And I'll tell you which technique you should use. And let's just put QQ on here and put regression. It's also regression or correlation. It's kind of a good practice right here. So what are you testing? I'm testing this and this. Height by grade level, freshman, sophomore. So that's with multiple grade levels, that would actually be an ANOVA. So an ANOVA is an analysis of variance, and an ANOVA would do that. So that could handle the multiple grade levels. So that would be multiple categorical, which we should put a caveat right here. Caveat. This is going to be the 2 sample t, and I think I accidentally did that one, or did I do that one on the? I said freshmen versus seniors. I think on the Quizlet. I think I said freshman versus senior. So if you test 2 grade levels, you can do a 2 sample t. The ANOVA does multiple t tests, so that would be a good one right there. Good job, Charlie. So that would be an ANOVA with multiple categorical, because that categorical is a 2-level categorical right there. Any other things we could test? We could test someone's height. What would we test someone's height with? So we don't do the ANOVA. That is correct. We don't do an ANOVA in 201. That is correct. No ANOVA. You're like, wait, what's an ANOVA, Brian? What is an ANOVA? What's an analysis of variance? 1 sample t. Yep. If we just want to test people's heights, we would just test a 1 sample t. What about if we want to test people's, let's say, what state they're born in and their favorite ice cream flavor? We'd probably need a huge sample size for this with as many categories if any statisticians are watching. Favorite ice cream flavor and state you're born in. Chi-squared test of independence. Let's say there's 10 ice cream flavors. How many degrees of freedom? Oh, there's 11 ice cream flavors. How many degrees of freedom would that test have? Oh, this is going to be a tough one. There's 11 ice cream flavors. It's not that tough. I made but then I didn't tell you the other part. Because we're doing favorite ice cream flavor by states. So how many degrees of freedom would there be? This is just a crazy question. It'd be 11 by 50. And so it'd be 10 times 49 equals 490. There'd be 490 degrees of freedom. So we didn't do the homogeneity test. That is correct. We didn't do the chi-squared test of homogeneity. We just did chi-squared test of independence. Woohoo! Because if there's 11 ice cream flavors, we're just stating that as a fact, and there's 50 states, it's an 11 by 50 matrix, and that reduces to a 10 by 49. So that's a good question right there, Tyler. When is it n-1? When is it n-1? This is a really good review that we're doing right here. When is it n-1? Boom, Charlie right there. Nice job, Charlie. So that is the 1 sample t has n-1. This one is complicated formula. And this one, so we'll never ask you to do the degrees of freedom for that. And then this one is rows minus 1 times columns minus 1. So there are how to calculate the degrees of freedom. Rows minus 1 times columns minus 1. Would there be a degrees of freedom for a two-sample? No. We will definitely not do this one. We will definitely not be doing the complicated formula for the degrees of freedom on the test. Definitely not. Not doing that. That is not on the test. I mean, we might, it could be alluded to, like, which one of these has a complicated formula? Does that make sense? We wouldn't actually have you solve it. We might say, like, match these or something. We wouldn't even show it, but we'd ask maybe a question like, which one of these has a complicated formula? Like, that's the way we've done it in the past, because we don't have you solve it by hand ever. We just have you plug it into a calculator, because it'd be like no one solves it by hand. It would just be a math problem then, which we don't do math here. We do statistics. So we care more about knowing what the degrees of freedom are used for, which I wish we asked that question on the exam. I don't think we asked it. But why do we have the degrees of freedom? What is the point of degrees of freedom? Like, we have degrees of freedom for the t, and we have degrees of freedom for the chi-squared. Why do we have degrees of freedom? And why does the 1 proportion z not have degrees of freedom? I'm really confused about what exactly we need to know, because the Homer and Pearsons are mind-boggling, and when I assume we won't use using applets on the file, that is correct. So when you think about it, a lot of it comes down to understanding the process, and you're still solving it. You're still solving everything you would solve on the homework and the Quizlets, except you're not going to get a z-score or a t-score and then plug it into the applets. So everything besides plugging things into applets you will be doing. So it's very similar to, and that's why we made the Canvas content quizzes. Has anyone ever felt that the Canvas content quizzes look a lot like the test? Like when you take the test, you're like, I saw this on the Canvas content quiz, or this looks a lot like the Canvas content quiz. And that's our goal with the Canvas content quizzes. So that way, you do my Pearson work that, you have to use the applets and stuff, but then we want to make sure students know, here's what the test will look like. Exam 2 had a bingo. And that's why we're like, do the Canvas content quizzes, know them. Also, once again, the Kahoots, big shout outs. The Kahoots have test questions on it. I'm still gonna do the one for tonight. Definitely practice, get it done, get it working good. We got it. So what is condition 1 for all of these? What is condition 1 for all of these? Every single one of these has what for condition 1? Every single one of these. Random, we gotta hit the button. Favorite button of all time. So, random. Random is condition 1. What is condition 2? And there's no order to these. There's no order to these, because someone's like, wait, condition 1? Why is it condition 1? There's no order. But it just makes sense to use this, because it helps us remember. It's like, okay, condition 1 is random. We need to randomly select the observations, so they're randomly selected. So we have random selection of observations. We don't pick things by the first convenience. We don't let things voluntary sample. And then we have 10%. What does 10% mean? 10%, called the 10% condition. What does this mean? Like, that's the thing we put on the test too. Like, what does the 10% condition mean? What does it mean? So be more specific, Tyler. I think you know it, but be a little bit more specific. Exactly. So you cannot sample more than 10% of the population or sample less than 10%. So no more than 10% of the population can be sampled, sample less than 10%. Violating it means you sample more than 10%. It's confusing to a lot of people, because you're like, why is sampling too much bad? It has to do with the way the statistics are calculated for finite populations, and there's an error that goes in when you have these sample sizes that exceed 10%. There's more error in the calculation. So we see this with large samples, and when we violate the 10% condition, they've shown it mathematically. It's a lot more details than I love to get into. I've looked through the papers on it, and I've been like, oh, that's fun. And then, I don't know, I skim them, my like cool math equations. I should try reading them again, because my knowledge keeps growing, and maybe one of these days I'll be able to communicate it. But I do understand the reasoning is because we get a larger error when we exceed this 10% in our calculations due to finite populations. Don't worry, you don't need to know that. Someone just put in the chat right now, what do you need to know about the 10% condition? Do not what? What do you don't need to know Brian's whole thing about finite populations, about the error in the calculations. Where can you find? I found one a long time ago. It was the most amazing thing, and it showed the mathematical equations, and it had a table. Maybe I just need to recreate it for myself, but it had a table of the percentages, the error that increases when you sample too much of a finite population. Maybe I could do it via simulation and recreate it. I don't know the mathematical equations like they do. But what is the only thing you need to know about the 10% condition? Like, what is the only thing, while we've gone on this big tirade right here, what is the only thing you need to know about the 10% condition? But you don't need to know why, like at this point, because that's do not use a sample size larger than 10% of the total population. Boom. That's it. I used to bring up the paper in class and everyone's eyes would glaze over and I was like, okay, this isn't getting us nowhere. So do not sample more than 10% of the population. Boom. Got it. Now, what do we do? Let's put a big red line right here. What do we do? This is not a condition. You pause. You need to now look and think about what variables you're talking about. So it really comes down to the variables. Now, here's the trick. When there's two variables, there'll be two extra conditions, I should say, which is 4 conditions total. When there's one variable you're working with, there'll only be one extra condition. It's just a way to memorize it for this class. If you do something enough, you finally memorize it without having to use any tricks. But for this right here, it will help because 3 is different for categorical and quantitative. Exactly. And if it's categorical, what will it be mainly? So we can see right here, and we'll do some abbreviations for it. If it's categorical, what will the third condition be? And we'll put a 1 right here. Condition 1, condition 2. So what will it be for categorical? What will it be for categorical? What will the third condition be for categorical? Going way back now. Which we did test for categorical. We did the 1 proportion Z test. What will it be for categorical? I'll give a hint. Here we go. What will it be? Oh no! I think I'm on ultra low latency. I think. What is that an abbreviation for? What is that an abbreviation for? What is S/F? What is S/F? Uh-oh. We need at least 10 watts success and failures. Exactly. So this is where you have NP and NQ must be greater than or equal to 10. So you need at least 10 successes and you need at least 10 failures. So when you think about a question related to this, it'd be something like, Brian wants to test to see if 40% of students like Taco Bell. He goes out and samples. Be very careful on this one. 100 students, and let's change it. We'll do 100 students, and only 8 of them like Taco Bell. I put a trick in here. I put a big trick. There's a trick in this question. Watch out. Does this pass the success failure condition? Does it pass the success failure condition? This is a test, and we'll just work it really quickly right here. So in this one, we're testing the null that the true proportion is equal to 40%. We have the alternative that the true proportion is not equal to 40%. This value right here is P0. That value right there is P0. P0 is what we are testing. So what are the amount of successes we expect, and what are the amount of failures that we expect? What are the amount of successes that we expect, and what are the amount of failures that we expect? Exactly. And always identify your notation. So identify all, and that's actually X right there. That's X. So that's X, and X over N equals P hat. So that's the sample proportion. That's the hypothesized proportion. That's the sample size. 8 is X. 8 is the number of successes. So 8 is how many successes were observed in the sample. And then X over N is P hat. And so we have right here that there are 8 successes in the sample. Now, we would not pass this for a confidence interval if we did a confidence interval, but we're not doing confidence intervals for this on test. It would pass. It would pass. Right here, there's at least 10 successes and 10 failures right there. So it would pass. And then if we do the test for this, we can find the z-score. So does that make sense? Exactly. So in a confidence interval, we use np hat and q hat. For a test, we use np naught and q naught. And so we would put right here p hat minus p naught over p naught times q naught over n square root. We plug in the numbers right here. Who here can calculate this out for me? Well, I can do it on the calculator too. So we put in 100. And good job, everybody. This is good practice right here. We just plug in the numbers. And then we plug in that. And we're going to probably get a pretty good z-score here. Like, oh, I reversed it. I was like, I should get a -1. And there we go. And so now let's find out. We're probably going to get like -5 or so. But 8. But that's for the sample. We're using np naught. And p naught, does that make sense, Tyler, right there? P naught is 0.40. So negative, oh, nice job, Charlie. Does that make sense, Tyler? I'm gonna double check. I'll show it in the calculator so people can watch. I trust Charlie, but just, there's that. There we go. Nice job, Charlie. And that'll make the z-score, we'll see in a second, I'll show. This one, we could kind of ask you what you think the z-score or what the p-value is. And Tyler, does that make sense? What I was saying, what the answer would be and why? We're all the way down here. And then we'll be all the way over here. The p-value is that. This is -6.53, and that's the z-score. So you're only worried about the condition with the original question, not what the sample provides. So I think I see the issue, and I'll explain right here. And the p-value will be 0. I'll just write here. P equals to 0.000, or it's about 0. It's very, 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 very tiny. If we put it into an applet, it'll basically say 0 by now. So when we do, this is where the confusion usually arises. For a confidence interval, success... So success failure for confidence intervals will be np hat nq hat greater than or equal to 10. For tests, it'll be np naught nq naught greater than or equal to 10. And even worse yet, I hate it when it does that. What makes it even more confusing is if we do it also for sampling distributions. Then with sampling distributions, it's NP greater than or equal to 10, NQ greater than or equal to 10. So this is a really confusing thing, but when you do tests, you use NP naught. When you do confidence intervals, you use NP hat. And when you do the sampling distribution, use NP. Does that help out, Tyler, at all? Really confusing right there. But it just depends on which one you're doing. And I can explain briefly right here. We're always trying to use NP. We're always trying to use NP. You might say, well, why don't we use NP if we're making a confidence interval? So you said the confidence interval won't be on. That is correct. The only thing that is on the exam of these is going to be this one. That's why I focused in on this one. We ended last time with the sampling distribution, or we start this one with the sampling distribution of the sample mean. So that is correct. The only one on the test is this one right here. So that's why I kind of focused in on it for a moment. I was like, let's do this one right here. But does that make sense? So that is the one on the test right there. That is on the test. So doing the test is on the test. So know that condition. Let's go back, look at the other conditions right here. What condition do we have for the one sample T? The one sample T has what condition? What condition do we have? No, you said you had said for the discuss failure and had no more than. Oh wait, no. So no. Oh, so sorry if I should have kept it up there, Tyler. With you want at least 10 successes and at least 10 failures, and with the question we just had right there, we had that P naught was equal to 40%, and N was equal to 100. And so don't look at X right there. We're doing NP naught. So when we do the success failure for the test, we're looking at how many successes we would expect due to the null value. Does that make more sense, Tyler? That this right here would be 40, and then the complement would be 60. So we expect 40 successes, we expect 60 failures, and it's due to P naught, not X. So X would be used if we were doing a confidence interval to test the success failure, but since we're doing a test, we use P naught. So if we were doing a confidence interval, we would use X. So if we're doing a confidence interval, so you're doing the P naught, not emphasize it. Exactly. In tests, you use P naught, and in confidence intervals, you would use X. So that is correct. So it would, interestingly enough, it would fail for doing a confidence interval, but it passes for doing the test. So if you would actually fail the condition if you want to make a confidence interval. Great questions right there, Tyler. And what am I doing right here? Near, I got to write it bigger than that. Nearly normal. Now, what am I trying to make clear right here? Sure, we'll do it this way. What am I trying to make clear right here? No, Tyler, keep asking. It's important. Like, I don't want you to make mistakes on the test, so keep asking. It's really confusing. I think the first semester I taught, I was like, wait, why are we using? It definitely confused me. I was like, wait, why is it NP naught, NP hat? You use it for one exactly. 1 and 2 sample T's. You'll look at the distributions to make sure they're nearly normal. And so we'll usually ask this in some sort of like theoretical way, but there's lots of ways to test the nearly normal. Normal distribution rules apply, exactly. So because both of these are trying to analyze a what variable. Since we're trying to see if the distribution is nearly normal, it's because both of these are trying to analyze a what variable. The goal of these is to understand a what variable. Like the goal of these is that we're trying to understand the context of a certain type of variable. Quantitative, exactly. So because the quantitative variable is the variable being analyzed right here, we have to make sure the distribution of the y variable, the one we want to understand, is nearly normal. And we can do that with quantitative distributions. So we have a few ways of doing this right here. We can, 1, look at a histogram. So you can look at the histogram of it. You can, 2, look at the normal quantile plot. Make sure that it follows the line. 3, you can do the goodness of fit test here. Make sure the p-value is greater than 0.05. So let's just put here a value that's greater than 0.05. Let's put here like this right here. A p-value that's greater than 0.05. And last but not least, on the nearly normal, you can, I'm thinking of the wrong one. You can use the large enough n. So large enough n. And the large enough n is when we check the shape of the distribution to make sure that the sample size is large enough that the central limit theorem will create a distribution of the mean that is nearly normal. Also, will you be reviewing tomorrow? Yep, I should be on tomorrow. I find reviewing with a human more helpful than trying to engage with the old videos and practice on. Yeah. No, that's why I'm on here, hopefully helping out and answering questions and going through. And we should understand these 4 ways right here. So we should understand. Is there any questions on this right here? So if you're watching live, it's one of the best ways to kind of make sure you're understanding and ask questions. Any of these ways right here, do you have questions on? We look at the histogram to see if it looks normal. It's not the best of ways. We look at the normal quantile plot, normal probability plot, make sure it follows a straight line or decently. We see if the p-value for the goodness of fit test is above 0.05, or we check the large enough n condition, which is basically the central limit theorem, to see if the distribution of the means is nearly normal. So those are 4 ways to look at the nearly normal condition. Just to clarify, sure, ask away. Any of these 4 ways that people want me to elaborate on. And let's do a data set with one of them. The top row is a summary of what variables are present. Yes, exactly. So the top one right here is when we analyze 1 categorical variable, 1 quantitative variable, a quantitative y with a categorical, 2 level categorical x, and 2 categorical variables. The normal quantile plot, the points should be between the lines, right? Pretty much. Oh, there might be a tiny bit of delay. I hope there's not too much of a delay today. I don't think there should be too much. And I think, cool. So let's look at credits this semester. Let's do it. So credits this semester. So the distribution looks... Really? Tell me how this looks. It's got a little bit of a what to it. It's unimodal, but it's got a little bit of what skew to it. What skew? Right skew, right to the high, left to low. And you can see the mean, that's actually the mean. And the diamond is actually a confidence interval for the mean. So you can actually tell that the confidence interval goes right down to about the median. There's the median of 15.15. And there's the bottom of the diamond at 15.03. And there's the top of the diamond at 15.4. And there's the middle of the diamond at 15.23. You don't need to know that, but it's kind of a neat thing that that diamond is the 95% confidence interval for the mean. So there's your 95% confidence interval, what we think the mean might be. And the middle of the diamond is the mean. So let's go ahead here and do a normal quantile plot. This looks slightly normal. The normal quantile plot will be extremely bent or mostly linear. The normal quantile plot will be extremely bent or mostly linear, which is also called a normal probability plot. It'll be extremely bent or mostly linear. Extremely bent or mostly linear when we look at it. What do you think it'll be? Extremely bent or mostly linear? Mostly linear, exactly. And that's mostly linear. So you notice it mostly follows this line. There's just a bunch of repeat data right here because it's integer value data. So we do see some kind of piling up of data points, but it mostly follows it. We see the outliers here at the end kind of deviating from the line. And that's what we shouldn't see for the normal curve. This looks mostly good. Probably looks good. Next, we can do the third way of testing it, which is the goodness of fit test. So we go to continuous fit. We add a normal curve. What this is going to do is it's going to draw a normal curve on top of it. And there's our normal curve drawn on top of it. There it is right there. You see some issues here. Too little, too much, too much. Some of this might be due to bin widths. So never trust your eyes because you can change the shape of this and make it look different. Why is my computer being slow? I should be able to put more bins in it than that. Oh, because it's integer data. I can't. It's because it's integers. And so now let's go over here and let's do the goodness of fit test. The goodness of fit test is the Shapiro-Wilk test. You don't need to know that, but the W we get right here is like a Z. And ooh, what does this come back telling us? What does this come back telling us right here? Might be hard to read. Which thing? Oh, I think I showed what Charlie was asking, the normal. It's less than 0.05. It's less than 0.05. But there's a saving grace, which is way number 4. And each of these ways, if you pass any of them, you're good. So if you pass, if you're like, wow, it looks really normal, you're good. If it looks really linear, like we probably could have passed it due to the normal quantile plot, normal probability plot. We probably could have passed it because of that. What is the fourth way and really the saving grace for this one? What is the fourth and final way and pretty much how we're going to save it? How are we going to save it? Because we can say, yeah, it's moderately skewed. If the question does not tell us, can we assume? Yeah, but exactly. Anytime you don't know an alpha, always assume 0.05. Great question right there, Rocky Top. Anytime you don't know alpha, always assume 0.05. It's the generally widely agreed upon alpha. Always assume 0.05. That is what people. If anyone says it was statistically significant, if they're not saying they're probably assuming 0.05. I've never heard anyone say it's statistically significant, and then they'll say at what level unless they're assuming 0.05. So what is way number 4? The fourth condition is the large enough n condition, which means we need to look at the sample size. And when we look at the sample size, so let's kind of review. This is the one where people get really confused. So when we do, so this is fourth way of checking nearly normal is large enough n. And when we do large enough n right here, what do we do? Or the fourth way is going to include first, look at the shape of the distribution. 2, know the associated sample size you need. And so the associated sample size would be 1 if normal, 25 if skewed, 100 if heavily skewed. 3, do you have this sample size? At least. I've seen people say, I don't have exactly that sample size. So I'm like, no, you just need at least that sample size. Okay, so this is kind of the way of doing it right here. Look at the shape of your distribution. So we could, I guess we put these right here. It's good enough right here. Look at the shape of your distribution. What does this look like shape-wise now? No, not that. What does this look like shape-wise here? We said it was skewed, right? Does that look heavily skewed or just moderate skew? Heavy or moderate skew? What do people think? Is that heavily skewed right here or moderately skewed? So I only see a few outliers, and I only see a little more pull on this quartile. I'd say moderate. Like, it's like, you can say minimum skew. It's, you know, it's not a big skew. So we're going to probably put it into this realm. So it's got a skew that is moderate. And what's our sample size? Our sample size is 306. And we need, as Charlie puts right there, so n needs to be greater than 25. And do we meet that? We definitely do. So we're good on this. So can we analyze the mean for this data? Can we use the nearly normal condition right here? Does it pass? Does it pass the nearly normal? Definitely. This definitely passes the nearly normal. So by the large enough n condition, we can say that we have a large enough sample size such that the distribution of the mean will be nearly normal. And we have to show this once again because people would be saying, everyone always says, but Brian, they say that it's not normal still. And let me pull up here, central limit theorem applet, because the crazy thing about this is we're not looking at the distribution of the single observations. We're looking at the distribution of the mean of so many observations. So we're going to take all those observations and get the mean of it. And we're talking about that distribution, and that distribution will be more normal and tighter. And that's some theory on the central limit theorem, that the distribution of the mean is always more normal and tighter, look at the difference between the tightness, than the original distribution. So that's a bit of a review right there, some really good stuff. And continuing on. So there's all the conditions right there. Or for that one, chi-squared, I like to do the condition here. That usually is condition number 4. But when you think, since you have 2 categorical variables, we want what? We want expected cells greater than or equal to 5. It doesn't matter if it's exactly expected cell count, exactly expected cells greater than or equal to 5. And so let's do a test right here to see if we know how to do expected cell counts. Let's go right here. Let's say whether or not someone owns a dog. We'll put yes, no. And then we'll put, let's say if they are let's say an athlete. So let's say here, athlete. We'll put athlete like that. And we'll put yes, no. And then we'll put right here 50, 80, and now 20 and 100. Does this pass? I can't math. Can't math today, everybody. Does this pass the expected cell count condition? Is this, you can ask some 320 questions. We can do 320 next. We're just reviewing. We're just reviewing as much as we can. It might pass them. It might pass. I'm doing the math right now. Charlie, you got to help me out. Let me think here. That's 800. Yeah, it just barely passes, doesn't it? Is it? I'm getting 6.666. Am I? Is that correct? Exactly. Top left. Exactly. That's what I got in my head when I was doing it. So how did we get that? Usually you check the smallest one right here, and that's the easiest way to check. So you go right here and you do row total times column total over grand total, and that will get you the expected cell count for each of these. And since this one is 6.666 all the way repeating, then it is going to pass the success failure condition. So that is not how many are in there, it's how many we would expect. And that is the formula row total times column total over grand total. And I like to draw it out right on there to show whether or not it passes. And we do, if you check the smallest one, then if the smallest passes, they all pass. And we're just doing the smallest row total, the smallest column total over the whole grand total. So this does pass the success failure condition. So that's how, the expected cell count, which is kind of like the success failure. What about the count data? You bet. That is condition number 4, which is count data. So did that pass count data? Did that one pass count data? Did that pass count data? Why or why not? It did. And why did it pass count data? Why did it pass count data? Count data just means both are categorical. So owning a dog is yes, no, categorical. Being an athlete is yes, no, categorical. So categorical data, boom. What is the last condition for 2 means? So is there a good review for 320 as for the PowerPoint? Yeah, I've got some of the slides up, and then I'll make sure, Lucas, let me send that out. And we've got let me send that out. Lucas, remind me, and I'll make sure it's pretty evident which are the good reviews. We've got tests posted for 320. I'd go over the tests. Also, Lucas, one of the biggest thing for 320 is definitely going to be the practice test that we gave. The practice test is huge because there are questions on the practice test. There's 20 questions, and I would say 30% of your test is taken from that. Does that make sense, Lucas? So the practice test is huge, and then the other practice tests are great, but the biggest thing to do for 320 is to know those practice questions inside and out, because you will see some of those practice questions on the final. So that's one of our big, like, here's what's really to study these topics, and then to know, like, especially those questions. Oh no, there's a moth in here. I'm gonna try to kill the moth real quick. Sorry, moth. Where am I on the screen? 2 seconds. Be right back. I think I got it. It landed on my green screen. I was like, I don't want to hit the green screen. Is there a summary sheet that's a little more detailed than the exam 3 formula and explains each formula we've learned and in tiny differences between them? I can go over that next, Rocky Top, if you want. What do we have as the final condition for the condition number 4 for 2 sample T? What is the final condition for the 2 sample T? What is the final condition for the 2 sample T? Oh, sorry, Lucky Top. Everything's going crazy. The world. So the final condition right here is independent means. I love technology too. Technology is just going crazy. Independent means. What does independent means mean? It means that both groups are independent of each other, as in, if you are testing students in class A and students in class B, that would be independent groups, because students in class A are going to make grades independent of students in class B. But what if you test students in class A after testing students, or before and after? Like, you give them a test and then you give them a second test, then their grades would be dependent. Probably one of my favorite examples with dependent means is when you do like a weight loss thing. Anyone who's ever done weight loss would know that your weights would be dependent before and after. No, so a lot of times especially on my Pearson, they mentioned random and independence, that you independently select your observations. But this is talking about the means right here, Charlie. Does that make sense? I'm going to expand my screen over there a little bit. Does it make sense that it's talking about the means? There's my screen. When we talk about independent means right here, we're talking about the means themselves. And we're saying that group 1 and group 2 are independent of each other, not that the data is collected independently. So hopefully that makes sense, Charlie. The big thing to think about is, like, imagine, here's 2 examples. In example 1, here's not independent means. So not independent means. We test people before and after a diet to check their weights. So that would be not independent, because someone's weight after a diet would depend on their weight before the diet. So that is not independent means. So independent means we have 2 diets and test each group after the diet to see how they performed. So now we have group 1 and group 2, and we're taking measurements on them after the diet. So this one with the before and after is going to depend, because someone's after weight is going to depend on their before weight. But in this one, the means are independent, because the mean for group 2 is not dependent on the mean for group 1. Like, if one diet's better, it'll be better. But in the first one, if someone weighs less to begin, then they'll lose less weight. So their weight after will depend on their before weight. So does that make sense how we have independent means in the second one? Because it doesn't matter what diet 1 does, diet 2 is going to do its own thing. And in the first one, we have dependent, where if someone starts out, really heavy, they have more weight to lose. If someone starts out really light, they have less weight to lose. And so their after weight is going to depend on their before weight. And this is where the two means are going to come from. Because in this top one, you'd have the mean of the before weights, and you'd have the mean of the after weights, and the mean of the after weights depends on the mean of the before weights. And in this one, you'd have mean for group 1 and you'd have mean for group 2, but the mean for group 1 and mean for group 2 don't depend on each other. If one diet's better, it'll do what it's going to do. Does that make sense what independent means mean? Independent means? Do you guys, if 320's here and has questions, feel free to ask. Lucas was asking questions about what's on the exam, and so I'm gonna fall asleep. Still tired. I need coffee. I don't want coffee. I need it. Variable sort notation for two means. Sure. Let's hop over to that. I'll write out a help me bring up the formula sheet, and let's go through the formula sheet. I think that's gonna be a big help. I'll do definitely more reviews for all the classes. So if you do have the opportunity, which many of our classes have the opportunity to take the test later, I would suggest taking it at a later time. 201 is at a very set time because it's a departmental exam, but 320 and 474 have more flexibility. Pros and cons to each class. Let's go over here, review material for exam 3. And let's pull up the formula sheet. And here is the formula sheet. And can I bring over to Word? I think I can. And then can I zoom in on it? Let's take screenshot here. It's the not fun thing about PowerPoint. Okay. Let's check this out right here. Here we go. Okay. So this is the very beginning of everything right here. We have the very, very beginning of all the material we covered. So does the exam close at 3:45 or do we have to... it closes at 3:45. It closes at 3:45. I'm going to send out an announcement today about it just to remind everybody that it's open from 12:30 to 3:45. Make sure to have a 90-minute window set. Make sure. So I'm going to send out a reminder today. A lot of people have been asking, but I'm definitely going to send a reminder to everybody. Would you recommend we put on our cheat sheets? For 320, I would say the biggest thing is understanding the interpretations where I probably see a lot of mistakes, Lucas. I'd probably put a lot of the questions we put on the 20 questions on there if I was in the class, because I've already been saying those are on the exam. So I'd put those on there to make sure I get them instantaneously. I'd put my interpretations on there. And other than that, I'd put conceptual stuff. So those are like the third ones are, I don't know, because then it's like, okay, interpretations are going to be on there. The questions, some of those 20 questions are going to be on there, but great questions right there, Lucas. That should set people up for success. And I see people losing points on interpretations, especially with logistic. So make sure to know how to do like multiple logistic interpretations. That's where I see people losing points. Lucas, great questions. Keep them up. So what do we see right here? Here's the very start of everything when we're doing the sampling distribution of the mean right here. And this stands for, we'll just take it step by step. We have here the mean. This is what we're doing the sampling distribution of for the mean. We could do it for the proportion, but we're doing it for the mean. This says the mean for the distribution of the sample mean, as in this is the mean for the distribution of the sample mean is equal to the mean. This basically means in layman's terms that if we know the average guy is 5'9" in height, if we took a sample of guys, what would we expect to see for the mean? So if we took a sample of guys, we would expect to see what? The expected mean for a sample of guys, if we know guys are 5'9" on average, we'd expect to see what? I said we know guys are 5'9". When I say we know guys are 5'9", that means we know the average height is 5'9". And then, then we would expect the sample mean that we observed on average to be 5'9". Because look at this, we're just saying that this is equal to this. So, or rather, the sample mean, the expected sample mean is equal to the mean. So, if you took a sample of GPAs at UT, what would you expect to see in your sample? What mean would you expect to see? You'd expect to see the mean GPA of UT students. If you know the mean GPA of UT students is like a 3.5, then if you took a sample, you'd expect the sample to have a mean of 3.5. That's what you expect. It's not saying it will happen. It's just where we're going to place the center of our distribution when we draw it. If the mean of GPAs is 3.5, then we would expect to see 3.5. So that's what we're saying is the mean of the distribution. Now, what do we need? We need some variation in the distribution, which is the standard deviation. So the variation in the distribution gives us this sort of standard deviation of 68, 95, 99.7 contained within the areas of the distribution. So the standard deviation, which is just variation, is simply going to be the original standard deviation, seen right here, over the square root of n, and that'll give us the standard deviation, which is how far away these marks are away from each other. So all we do is we plug in whatever the original standard deviation is. It might say the original standard deviation for this is, let's say, 0.2. So the original standard deviation is 0.2, and the sample size is 100. So what would be the standard deviation? You're welcome, Lucas, so much. Could the review for the final correct answers be released since it was finalized yesterday? I can't view those 20 questions on my end. Let me send out a reminder tonight, and then we'll put out the final questions because some people haven't finished it. And so they're allowed to do it late for points, but that's a great idea, Lucas. Definitely. So we'll, I think we should be able to release those correct answers. And then, yeah, can I change that right now? Let me change it so you can see your correct answers. Because people are already, it's unfortunate. People are, if someone hasn't done it, they're losing points. Okay, here we go. Okay. You got it, Lucas. Lucas, it is fixed. You asked, you shall receive. Thank you so much, Lucas, for the questions. Tell me if you can see your correct answers now, Lucas. I actually had it up because I was making changes to it. I think I changed the right thing. I think I did. Yeah, I think I did. I had the right thing up right there. Tell me if you can see the right answers, Lucas. And thank you for asking. Sometimes all you got to do is ask. And say, hey, can you do this? I'm like, yeah, let's just do that. Because if people are finishing it now, they're losing points for turning it in late. Because we don't want students to turn that in late. They do have the advantage of seeing what they get right or wrong. Unknown phone number. But Lucas, you should be able to see it now. And who knows what the new standard deviation for the distribution of the sample mean will be right here. What would be the new standard deviation for the distribution of the sample mean? We're just like hopping topics. What would be the new standard deviation for the distribution of the sample mean? What would be the new standard deviation for the distribution of the sample mean? What would be the new standard deviation? It would be equal to 0.02, a little tiny. 0.02, the distribution, or the standard deviation for the distribution of the sample mean would be 0.02. And we solved the mathematics there with just the numbers I gave for this, saying we took a sample size of 100 and has a standard deviation of 0.2. That's the standard deviation for the population. This is the sample size we took. And then we would expect the sample mean right down here to have a standard deviation of 0.2. It's a smaller based on the larger sample size. It decreases the variation. It says the quiz can only be viewed a single time after its submission. I shouldn't have closed it. Let me fix that. It says it can only be viewed a single time after its submission. I should not have closed it off right there. Here we go. Let me try fixing that up again. Thank you, Lucas, for the... Why would it say that? Why so serious? Okay. Only let students see their quiz responses only once after each attempt. Okay, cool. Cool. Okay, give it a shot now. Try doing it now. Did you figure out an answer to my, about the East and the West? I don't know. We could just reorient ourselves. It is weird, isn't it? You know why? Because I know why, Andrew. I figured out the answer. There's no East and West division, but North and South have hemispheres, which make North and South relative. So since there's the Northern and Southern hemisphere, it's then relative. But is there I think that might be the answer. Between the standard deviation and the ones with P's and Q's. Yeah, we're about to do some P's and Q's. You got it. And right here, we'll finish up the next one down here because we'll go to the next part of the formula sheet. We have right here that the z-score is equal to the observed sample mean minus the mean we have for... Ooh, that's a typo. That should not have a naught right there. Let me tell Terry. Take away that naught. So this, and it should be mu y bar technically, or mu's fine because it's mu y bar. Exam 3 is not really cumulative. We just have kind of the, good to see you here, Charles, right there. We do have, what are they called? Tools and techniques questions, which can ask you, like, which tool would you use? It's not really cumulative. It might ask you, though, what have you learned in the past that you might use? So don't start reviewing all your chapters. Kind of understand, like, tools and techniques questions, which I can do one here in a moment if you'd like. A tools and techniques question for this one would be something like, we want to analyze a distribution of 100 UT students to see what GPA we would expect on average. And so we know their GPA, so we have a known GPA right here. And we're going to use that to give us what we expect to see in a sample. And then we can also figure out the variation we expect to see in the sample right here. So this is the sampling distribution of the sample mean when we have a known distribution. And then we can see if the sample we observed is odd compared to the mean. So next, the one sample tests right here. So Rocky Top was asking about, and just making sure, confidence intervals. And we don't have confidence intervals on this test for that. Everything here does look accurate. I'm like worried something's not accurate. Oh, I don't like how that's abbreviated. Sure. I just hate that it's abbreviated that way. Okay, everything is correct. I got worried because I saw one error, and I was like, please don't let there be any other errors. So let's take a look at what we have right here. We have the confidence interval, which confidence intervals, did we do it? Oh, that is, yeah. I don't think it is on this test. I'm going to double check. It's on the formula sheet, but sampling distribution of the sample mean is where we started. And so maybe it is on this test. Maybe confidence intervals for the, we've changed the orders of the chapters, and I'm just like, I know we start at sampling distribution of the sample mean. I'm just trying to remember. But we have right here, Rocky Top was asking about the P and the Q. So let's start with the very beginning right here. P hat right here is what? We need to know instantaneously what P hat is. What is P hat? What is P hat? We should know that instantaneously. And how do we find P hat? What is P hat? X over N. X over N, and it's the sample proportion. So P hat is X over N. X is successes. And N is trials, number of observations, or just sample size, trials, number of observations. So we'll just put here number of obs. So it's the sample proportion, exactly. So number of obs. So the X is the number of successes, and the N is the number of trials. So if I told you I went out and sampled 40 UT students, and 12 of them were from North Carolina, what would be the sample proportion? I went out and sampled 40 UT students, and 12 of them were from North Carolina. Well, X would be 12, and the sample size would be 40. There we go. Yep, that's the sample proportion. So that's what the P hat right there is. That is the sample proportion. So now we need to know what Z is. Z is going to be relative to our confidence. So Z is relative to our confidence, and it has a star because we get to pick it. Classic Z's are like 1.96, which is a 95% confidence roll, or like 1.6449. Okay. Statisticians like, why? That's a 90% confidence roll. You don't need to memorize these. We will tell you these. But what do you notice right here? Like if I do 2.5758, can anyone guess what percent confidence this is? 2.5758. What percent confidence do you think it is? This is. We could make this a multiple choice question on the test. Like that is a technical possible question. Like I don't think it's on there, but if we said a z-score of 2.5758 would be used for what percent confidence? We could have like 92, 94, 99, or 80. Oh, I think I know what Andrew knows. Andrew's thinking of 3. That's the z-score of 3, Andrew. 99.73, because I always love adding that 3 on there. That is for the 3. That is for a z-score of 3. But that's a good guess. Good guess right there, Andrew. Coming in with the knowledge. So this one has to be bigger because when the z-score gets bigger, the confidence interval goes out further. So this is actually a 99% confidence. 99% confidence. We're on a new page right here. It goes 1.2818. No, 16. I always get that one wrong. I've started to correct it. This is going to be a 80%, 1.645 is a 90%. 1.96 is 95%. 2.3263 is 98%. And 2.5758 is 99%. And then there's numbers between, but if you notice, the z-score gets bigger and bigger and bigger, and the confidence level goes up with it. So when you go further out, it gets more and more confident. And I'll just show it here visually for a second. Let's go to stat distributions, and let's look at it just so we can see what's going on and make sure people understand that the z-score controls the percent confidence. So we're going to see the exact numbers I've got written on the screen here. They might be rounded a little bit differently, like that rounded to that. So 1.2816, 1.645, 1.96, 2.3263. I swear it's 2.263. And just so everyone, well, don't worry about it. Someone's going to say it's not. Someone's going to say Brian got that one wrong, but I know it and I hate that applet for that reason. I love it otherwise. But if we go here to QNorm, we type in this, we should get 2.3263. There it is right there. And I don't know why that applet changes it. That drives me absolutely nuts. So we've seen these answers right here, and we understand as the z-score gets bigger, the confidence interval gets bigger. So as the z-score gets bigger, the confidence interval gets bigger. Very important to know that about the z-score. So the z-score controls the percent confidence. This is the other component of the what. Everything Brian has highlighted right now is the what for the interval. Everything I have highlighted right now is the what for the interval. Everything I've highlighted right there or right here. Margin of error. Nice job, Charlie. Those are the margins of error. And so it's kind of good to understand what's going on right here, and that everything after the plus or minus is the margin of error. I've highlighted on multiple intervals right here. So the margin of error shows us the after the plus or minus, it makes the interval symmetric, but all of those are the margin of error for any interval. And what do we have right here? The margin of error is going to be equal to the standard error, which is p hat times q hat over n. If p hat is equal to 0.3, so if p hat is equal to 0.3, what is q hat equal to? If p hat is equal to 0.3, what is q hat equal to? These are things we should know like that now. Like p hat and q hat are what's of each other. They're complements. So if p hat is 0.3, we should instantaneously know 0.7. Boom, right there, 0.7. Yep. If p hat is 0.3, q hat is 0.7, instantaneously know that they're complements. You just subtract 1. So in case you're worried, you just take 1 minus p hat, and that is q hat. They should add up to 1. And you just divide by the sample size. So that's the sample proportion minus the complement of the sample proportion over the sample size. And that gives you this value right here. The next formula is very similar to it. We have for the next formula the sample proportion minus the hypothesized. Now, when we do a hypothesize, this is what we're going to use for our hypothesis test. So whenever you have this value right here that I've highlighted, this value with the naught is always going to be the value right over here. So remember, the null has the equal sign. So the null always has the equal sign. The alternative can be less than, greater than, or not equal to. And we're going to test the true proportion for this test. And whatever we have right there is the value right here. So that is the hypothesized value. And the same works for the next test down below. So if you were looking at this test down here with mu naught, well, when we're doing mu naught, well, then we're testing to see if the mean is equal to some hypothesized mean. So mu naught right here is the value you are testing, and it goes right there into the hypothesized value. So it's always important to see where these values are at and follow them throughout multiple examples. So you can notice how testing works the same way. This first value we see right here in this equation is our sample value, and this is our hypothesized true value. And then we have to take this difference and standardize it. So here is the standard deviation. So all of these tests are just a difference standardized. So whenever you look at a test right here, the top part of the test, let's put it in yellow, is just a difference. And the bottom part of the test will just be a standardization of that difference. So you can see right here, the top part on every one of these, it might be hard to see with the zoom out. I'll zoom out across them. but the top part is just a difference, and then the bottom part is just a standardization of those differences. So we take a difference and we standardize it, and that gives us these test statistics right here. All of these test statistics for the tests, not the confidence intervals, but all the test statistics for the tests are standardized differences. We're just taking the difference between the sample proportion and our hypothesized, or the sample mean and our hypothesized mean. How long have you been live? About a little hour, 15 minutes. I know I said go live at like 3, Nikki, and I was like, oh, let's go live earlier. So we've been going through the formula sheet. We went through the conditions. Lots of good stuff right now in this video. So hopefully this helps people out a lot. I don't know. I was like, let's get on. Let's do it. Let's start doing it. I need some more water here soon, though. We're running out of water. So all of these right here, the first thing we see right here is the sample proportion minus the hypothesized proportion. The sample mean minus the hypothesized. See how it's got the naught right there? The hypothesized mean. The sample difference, and 0 is what we want to be true. So follow the guideline right here with this. What do you think 0 is? This is the sample mean minus the hypothesized mean. This is the sample difference. And so 0 is the what? Because when you write this out, so what do you think 0 is? Because we can write the null is that mu1 minus mu2. Bingo, Charlie, exactly. It's the hypothesized difference. Because we hypothesize there's no difference. And so you don't have to put the 0 there. You could technically not have 0 there because it's minus 0. So all you're doing is taking the difference, and yeah, but 0 is the hypothesized difference between the sample means. So we can write it in this format, and you can technically, for all the stats people out there, you can do this. We've never done this on a single. I think we did this one time actually, like 9 years ago. You can test. Oh, good. What happened there? You can test different values. You can technically test different differences. That's something a statistician one time, he's like, I didn't know that. And I was like, yeah, you use different hypothesized values. He's like, oh yeah, I guess that makes sense. We won't do that on our test. That is not on the test, not on the test. But you can technically do that. Not on the test. So what do we notice right here? Just this is the hypothesized proportion times the hypothesized complement of the proportion. And this is whatever the problem tells you is true. If you're wondering what P naught is maybe right now. Here is a question. You ready? Let's see if we can identify P naught. Identify P naught in this question. A researcher wants to know if students have eaten at Mellow Mushroom on campus. They believe that over half of students have eaten there. From a sample of 200 students, they find 90 students have eaten there. So what is P naught? Okay, what is P naught? What is P naught? So what is P naught in this problem? Then we can find Q naught like that. And actually, I should have made... Oh, I don't want to change it now. There we go. Be careful. So 90 is going to be what? So that is P hat. That is correct, Charlie. That is P hat. So 90, identify notation immediately when you get a problem. Anytime you get a problem, identify notation. So what is 90? What is 200? What is 90? What is 200? Identify notation immediately. Always look at it, identify notation. Oh, it's greater. Are you saying it's greater than 10? Exactly. So this is x, and this is n, and we know that p hat is equal to x over n. So p hat is equal to 0.45. So that is p hat. So, do you see any other thing on here that could help you find something? What is P naught? Exactly. That is P naught. So that is what they believe or they're testing. So now when we do the test, they want to see, and I slightly changed it, they want to see if it is 50% the true proportion is 50%, or the true proportion is not 50%. So that'd be the test right there. Does that make sense? Yeah, great job, Rocky Top. Excellent work. Yep, you got it. That's Pinot right there. Yeah, that's, I said over half, so they would definitely fail to reject this null, excuse me. So if we change it back, then the alternative would be that. I did say over half to begin with. So and I changed it. I don't know why, because of the data. I wanted it to be like consistent, because this one you would definitely fail to reject the null, because you don't, even in your data, it does not support the conclusion at all, because you have less than half. And if you want to see the more than half, well, then there's no, your data goes against that. You'd only have evidence of maybe less than, but even this is kind of close. So I doubt it would reject for that even. Does this make sense right here, how we identify the notation for this? We're just kind of going over identifying notation right now and being able to read a problem and then correctly identify notation. Which if you can do this is, you basically, why is it greater than? Oh yeah, no, it's right now. Right now it's this. This one gives no preference. Previously, when I said over half, then it would be greater than. Yeah, no, Charlie, that's my mistake, because I changed it and then I changed it back, and yeah, that is correct right now. So it's my fault, because I did originally say over half, and then it would be greater than, but hopefully I didn't confuse anybody with that. I wrote it differently. If you rewind the tape, I was like, yeah, we'll change what this is. So I hope this all is identified up top. So let's look at this equation right here, and all the mathematics right here. Y bar is the what? Y bar is the what? Y bar is the what? We should see Y bar and be like, oh, that's the blank blank. The sample mean, yep. Y bar is the sample mean. So it's like we went out and took a sample of 100 students and they had a GPA of 3.8. So that's a sample mean for a sample size. And then the T with degrees of freedom. So the degrees of freedom right here are n-1. That's important to note that we're using n-1 degrees of freedom, sample size -1. And the T star means you get to pick it. Now, we won't have you find the T star on the exam unless we're doing some sort of algebra problem, which we have done, but you won't have to look it up via a table or anything, because it's so much easier to just use an applet. But you won't be using applets on the exam. So we'll just basically give you these numbers. We'll say like the T for this is this. We have had people pick a T before. And what I mean by that is, imagine we said, let's do this. We have a sample of 61 students, and there was a mean of 3.5 in their GPA, with a standard deviation of 0.2. What is the proper T to use? We've done stuff like this. So we've done this before. Don't capitalize my T. Sure. And then we'd give the values here. So what is the proper T to use right here? So which of these would be the proper T to use right here? This is what we do if we have you pick your T on the test. Exactly. T is 60 degrees of freedom. So why 60 degrees of freedom? n-1. So we won't actually have you find the T, but I wouldn't want someone to be like, you said we didn't have to find it. And they're like, why do we have to do this? And it's like, well, we're asking you, basically it's like, what are the degrees of freedom is the question. It's just the knowing the notation that means a T with 60 degrees of freedom. Will the tests be mean and give us superfluous information to confuse us? I don't like superfluous information questions. I mean, I understand why people do stuff like that. I've never liked those types of questions. I don't like that way of testing. I've never been a big fan of that. I don't think many of our questions usually include that. Anytime I write a question, I just get to the point. Yeah, it's like, why are you wasting my time? Why do we encourage these types of test questions? I guess they want you to sift through information you don't need, but I don't like it. I don't like it. Just put more questions on there. If you want to give me more information, give me more questions, not more junk information. The standard error. We're on to the standard error now. We'll talk about this other stuff here in a minute again. But I'll admit, I give it to my students. Rocky Top, no, don't do that. But I always apologize for being mean afterwards. The standard error is the variation. It's just S over square root of N. It's the original sample size, standard deviation for the sample. I can't even think today. Don't even know what day it is. the standard deviation for the sample over the sample size. And so we just take the original standard deviation of the sample, divide it by the sample size, and square root of the sample size, and we're done. So just put it into this formula. You got the formula page, good to go, and you got it. So that is a confidence interval for the true mean made from the sample mean. Here we are trying to figure out the T-statistic, and I do want to point out that these are not the same thing. These are not the same thing. Let's just put an X between them. These are not the same thing. That T with the star means you get to pick it, and it's based on your confidence level. The T down below right here is the difference standardized. It's the difference up top standardized down here. So make sure you know that. And let's see. So we have, oh, these are, oh, no worries. So this is your sample mean. This is your hypothesized mean, which means we just state it in the problem. Like this is where we want to do the test. And then this is the standard deviation over the square root of n. So Charlie, try writing this test question here. Just say like a researcher wants to go out and test such and such. They collect such and such and such and such and be able to identify what the numbers are. Like this is the way to really know it, is to write a test question yourself. And I'm going to see if I can answer your questions, Charlie. So Charlie, I want you to write a question where you say, a researcher wants to test blank, blank, blank. They believe blank, blank, blank. They, and so always look for what are they testing? Like what's the tested value? What's the data they collect? And if you get in the practice of doing this right here, if you can write a test question like this instantaneously, you really know the material. So let's see, or anyone else is free to do it too right now for practice. But if you can write your own test questions, you've got it down. That's when you know the material. Because then you know what you have to create for it. I have to create a sample mean. I have to create a sample standard deviation. I have to create a sample size. I have to create a hypothesized mean. And then you understand how to word them. So writing your own test questions is key. I wish I could do more where I had students write test questions and I solve them. Like would say like stump Brian with your test questions. I don't know. Would that be a good idea? I really believe if students can write test questions, they understand the material, because you have to. You have to know the material to write a test question. So let's see. Can anyone write a test question here? I'll give it a moment longer. So you need to figure out the sample mean, the sample standard deviation, the sample size, and the hypothesized mean. And the degrees of freedom can be found from the sample size. We will see. Oh no, no test questions. I'll do one. People might be afraid to do it. A researcher wants to test here we go, mile times. Boom, got it. A researcher wants to test the mile times for students. The true mile time is thought to be this. Okay, yeah, they believe. Let me change this just slightly right here. They believe students run miles in 8.3 minutes. There we go. A sample of 200 students taken and 45 students had a mile time below. Okay, so wait, a sample of 200 students is taken. So this would be a proportion test. With the way you're doing it right now, it'd be the proportion because you're seeing whether or not students have a mile time above or below this. So let's change this just slightly right here. Is taken, and we find a mean of 7.3 with a standard deviation of let's say 0.5. Now I'm going to make this a nice problem, and I'll tell you why. That makes the problem super easy enough that I can do it in my head. The answer is the T-statistic is -20. How am I able to do that? The problem is extremely nice now because let's take a look at what we have right here. We have a sample size of 100. With a sample size of 100, when we do our test, we'll be taking the square root of that. That makes the problem way, way easier just to do in your head. What are the other things in this problem right now? What are the other bits of notation? And great job, Charlie. Thank you so much. This is great practice. And it's not 2 standard deviations below the mean because we're not going to do standard deviations here. This is where people get tricked because the formula right here, and I'll write out the formula, is going to be T equals, and T with degrees of freedom because this is a 99 degrees of freedom right here. So we can say df equals to 99. This is equal to the sample mean. I can never write. The sample mean minus the hypothesized mean over S over square root of N. So, yep. And it's technically mu naught. So mu naught right here. So this gives us the null hypothesis, which I'm completely blocking. The null hypothesis is that the true mean is equal to 8.3. The alternative would be that the true mean is not equal to 8.3. So now we see, and you have y bar. Yep, y bar is equal to 7.3. And this is equal to S. And we have everything. Mu naught is the hypothesized mean, and mu is the true mean. Yep, exactly. Mu is the true mean, and mu naught is the hypothesized. So you don't want to say the true mean is this when you do a test. You want to say we hypothesize that the true mean is this. Because remember, we're saying right here, the null states that we hypothesize that the true mean is equal to 8.3. And so whatever you put in the value right here is whatever you're hypothesizing is true. Does that make sense, Charlie? That in this position, we have what we hypothesize the true mean is equal to. So we don't know what the true mean is. We're hypothesizing what the true mean is equal to. Yeah, and then when you take mu y, so that goes back to the previous one. Mu y bar is the mean for the sample mean is equal to the mean. And that's when you know the true means. That's a different concept right there, that when you know the true mean, you can say what you would expect to see in a sample when you take a sample. Does that make sense? So this one, we don't know the true mean, so we're doing a hypothesis of what the true mean might be. So that's sampling distribution of the sample mean versus testing the true mean, or a test on the true mean. So hopefully that didn't cause any confusion, because we jumped chapters there. But no, I want to explain everything I can. So the sample. So this one is a one. This is a two-sided. It's a one sample two-tailed T, which is two-sided. So this is a one sample two-tailed T. So this is a one sample T test with two sides to it because of the does not equals. This right here controls the sidedness of the test, but it's a one sample T because of this right here. Yeah, exactly. And then the one-sided test would be the less than or the greater than, and the does not equal. So these are one-sided tests or one-tailed tests, and that's the two-tailed test. So good question. So the less than looks like that, one-sided. The greater than looks like this, one-sided. And actually, we should draw it where we can find out the mathematics on these. And then the two-tailed test is where you take it and reflect it on the other side. So that's the two-tailed test. And so if you'll see the mathematics right here, you'll notice that this just turns into -1 over 0.05, which is equal to -20. And that's going to be ridiculous. That's going to be so far off the curve. When you talk about a t-score of -20, it's all the way down here, and then the reflection would be all the way up here, and the p-value is equal to 0, basically 0, because there's no area that far away. We landed extremely far away. So this is the t right here, the t with 99 degrees of freedom, and the p-value would basically be 0 for all intents and purposes. Does that does that make more sense on this test right here, Charlie, that we just did? Does it make sense to write it out more and to understand where we have these formulas going into place? Can we do a two-sample T with this question? Yeah. Let's do that. Let's hop to here and do basically the same thing, but go to our two-sample T test now, and notice the small difference here. How do we need to change this question to make it a two-sample T test? What do we need in this question right here to make it a two-sample T test? What do we need to make this a two-sample T test? So we need two samples is what we need. What does it mean to have two samples? It means you have two groups. So who should we test? Test Florida versus... So correct. They're both T-statistics, but the T-star is decided on by the confidence level of the interval. So when you use T-star, you're saying I'm picking this based on the confidence. When you're doing the T from the T-test, it's the T standardized by the difference. So just to kind of explain that briefly right here, when you... that's the screenshot of it. Go away. When you have the T-star right here, this is picked based on the level of confidence. When you do the T right here, you don't pick this T. This T is decided by the difference standardized, and then you plug it in to get the p-value. So it's really like one of these, you go, what is the percent confidence? That tells me my T. This one you say, what is my t? That tells me my p-value. Does that make sense? So they're both t-statistics, but in the first one you say, what % confidence interval am I building? This tells me my t. This one you say, what is the difference standardized? That tells me my t, and then you go find the p-value from that. So you get to pick your t here based on the confidence level, and then down here you solve the difference standardized. It's basically just the t is always a standardized difference, and we use it to make confidence intervals, or we use it for the test. So build a confidence interval for the two means. Yeah, exactly. If we said build a confidence interval, we'd be using this, and then you would know the t like that. You'd be like, oh, the t with 90% confidence is this. But then if we say let's test something, then you solve for t based on the difference standardized. So when you test it, you get the t that is the standardized difference. When you build a confidence interval, the t is always based on the confidence level. So, and the degrees of freedom too. But that one you get to pick based on your question. You don't, yep. Hopefully that makes sense, Charlie. That's a big question a lot of people have wondered. So let's hear it here. A researcher wants to test mile time for students from UT and Florida. They believe UT students are faster. Of course. A sample of 100 Florida students. And just to break this apart to make this easier, and there we go. So can you identify everything in this question now? And understand that we are testing right here. So we're going to test the difference between the null is going to be that mu UT minus mu Florida. And if UT is faster, then, well, one, the null always has the equal sign. And the alternative is going to be, oh my gosh. If UT is faster, then this should be a positive difference. So it should be greater than 0. Because Florida would have a larger time. And I think Charlie's got right here y bar 1. And so this is going to be exactly, this is going to be a y bar. And you can put here y bar Florida. S Florida and SUT and Y bar UT, and this is NF and NUT. There we go right there. And that is how we identify what the problem is. It's a 2-sample T because there's 2 groups. Is there somewhere I can find help for the content quiz? Yep, the Kahoot we did on, let me post that link in here. Good question, Megan. The Kahoot we did just a little while ago. So, got 16 people watching. Hey, thank you everyone for being here. Try to do some more reviews tomorrow. Let me put a big thing. I've posted this a lot, but probably, and I know people like love live videos. That's where I'm going to try to do more live videos. Let me put this in the chat if you haven't seen it. Well, one here is, there it is, practice test 3. So I'm going to drop this link in the chat. This link has kind of my condensed reviews because we're just kind of answering questions right here. I just totally hadn't. What is that epiphany, Andrew? So I'm listening to the music right now. And let's go over here to the streamed 1 week ago. Okay, this is the one we want to watch. Okay, and this is the one we did for November 23rd. That is correct. Cool. So this is Canvas Content Quiz Help. This covers many of the questions on the Canvas content. Technically, there's no east and west, only north and south. There's no true east and... There you go. There's no true east and west. Andrew figured that. I love it, Andrew. I love it. Oh, you're right. Because of the magnetic poles. There is no magnetic east or west. That's a really good answer, Andrew. I like that. There's no magnetic east or west. There's just magnetic poles. So that's how we have east, north, and south. We don't have a magnetic, because you can go towards, yeah, it means you're going towards or away from something. So, but it means you're going towards the South Pole. You're going, because there's poles. There's no, yeah, and that's the thing is there is a spot that is true north. Like you can't go any more north than that. You're always, you'll start going south. So there's a destination. There's a North Pole. There's a South Pole. There's no East Pole or no West Pole. I think you figured it out, Andrew. There is no destination that is true east or true west, but there is a true North Pole and true South Pole. at least by the way we've identified them. Go me. That's what I love it, Andrew. And you see, now I can answer that question. Did you think of that original question? Because that's a good original question. Like why when you go completely north, you start going south, but when you keep going west, you never start going east? Really good question. Really good kind of just like thinking. TikTok. Well, you tell them on TikTok, because there is a destination you can go towards when you go north and south, and there's no destination you can go towards when you go east and west. There's no point to which you've reached that destination. Megan. Oh, hopefully we're not trying to give you the midlife crisis, Megan. So don't worry. I keep thinking I'm at a midlife crisis. I don't know. When do you have a midlife crisis? Is it 40? I'm getting close. So what do we have right here? We have the standardized difference, and we just kind of covered what this means. This is sample mean 1 minus sample mean 2, just the means for whatever groups you're talking about. This is the standard error for the difference between the sample means. And we see right here the formula for standard deviation 1, standard deviation 2, sample size 1, and sample size 2. So we have everything. I'm in my quarter life crisis. The midlife crisis comes pretty quick. Yeah, let's all live to 100. Then we can be at, I'm at my 38% life crisis. Not even near there. So we've identified everything in these formulas here. Let's go to the next formula. We have the chi-squared is the sum of the observed minus the expected squared. But let's break down further what these are. We talked about expecteds earlier. Expecteds, what are expecteds? Well, when you think about an expected, just think of it this way. If I told you half my class is going to fail the exam, the other half is going to pass, and half of my class is online and half of my class is in person. So we have online and in person, OP. And then we have right here fail, and we have here pass. How many of my online students do you expect to fail? This is a horrible thing. Sorry, Rocky Top. We'll change it here in a second. We'll change it to make it nicer. How many of my online students do you expect to fail? How many of my online students would you expect to fail? We're looking at this formula right here. How many of my online students would you expect to fail? Row total times column total over grand total. 25. Boom, right there. Nice job, Andrew. Row total, there's row total times column total over grand total. And that gives you that right there. And just think, half my students are online, half my students fail. You would expect that right there. Why do you do that when I zoom out? I hate that it does that. Sometimes it changes the page dramatically. Well, let's change the numbers, make them look nicer here. Let's make the numbers look a lot nicer with, let's say, only 10% of my students fail. Now I'm going to pick 12 for a reason. I'm taking 12 for a reason, so we need to change this number here. There we go. 12 of my students fail, 88 pass. How many of my students online students would you expect to fail now? How many online students would you expect to fail now? We have to have at least 5 expected to do the test. We have to have at least 5 expected, and I chose 12 for a reason. Don't worry about if you have exactly 5. We won't put that on the test. I don't like that type of question, because then does 5 even really exist as a number in number theories? Hopefully it's less than 1. I agree. And so it'd be 6 right here, and that's the expected, because row total times column total. Oh, that's that's O right there. Good. Row total times column total over grand total. So that would equal to 6 right there, and that's the expected amount. So we'd expect 6 right there. And hopefully you're seeing the formula, row total times column total over grand total. And then what do? We need to find out the chi-squared. Let's say only 2 of my students. So we observe only 2 students here, 10 here, 40 here, and 48 here. So what would be the chi-squared for this cell? So remember, this cell right here, we observed 2. I observed 2 students, 2 online students failing. So I observed 2 online students failing. What is the chi-squared for that cell? We have to go in, and we have to take the observed minus the expected squared. So we observe 2, and we expect 6. We square that, and we divide by the expected. So this would give us the cell chi-squared for this. The cell chi-squared here is going to be 16 divided by 6, which is going to be 2.666. So I think, unless someone correct me if I'm wrong, that is the cell chi-squared for this cell. Now you have to find all of the cell chi-squareds and add them up. And that is the chi-squared test statistic when you take all of the cell chi-squareds and add them up. But we just take the observed, which there were 2 students we observed. We expected 6. How was the 6 found again? It is the formula row total times column. There's the row total times the column total over the grand total for that cell. And you have to do this for all of the cells. You have to find the expecteds for all the cells. You have to find the cell chi-squares for all the cells. And then you take the sum of all the cell chi-squareds to get the chi-squared test statistic. From here, one of the easiest questions I can ask you right now are, what are the degrees of freedom for this test? What are the degrees of freedom for this test? And we covered this earlier. What are the degrees of freedom for this test I just did right here? 1. Brian, this is a 2 by 2, 1 times 1, 1 degree of freedom. So what if I told you we're going to do a test where we have 4 class levels? We have class level, let's do it this way. I don't like that. Freshman, sophomore, junior, so junior and senior. There we go. Freshman, sophomore, junior, and senior. And then we have here that we're going to test if they pass, if they fail, or withdrew from the class. So how many degrees of freedom are there on this test? Super seniors. We could add them in, and we can see how that changes it. There are 6 degrees of freedom. One real quick way to check is to delete 1 row and 1 column, and then you are left with 6 degrees of freedom. And there they are. Also, I always like saying, Brian, this is a 3 by 4. That reduces to 2 times 3, and that is 6 degrees of freedom. So that is how we can get the degrees of freedom just like that. And I think we've done almost 2 hours of review right now, and the 2-hour videos take sometimes a little bit to post. That's why I try not to go over the 2-hour mark. What is everyone thinking? What questions are there? I think we're right at, what time did we start? I think we're almost near the 2-hour mark. So great job on the points. Good to see you here, Griffin. Everyone getting points. I'm going to try to make it. I'm trying to work with Mubot. Andrew just destroying the points. Andrew's got his quotes, got his points. Quote 39 should be there. Mubot, you awake? Where's your quote 39, Mubot? Quote 39's in there, right? Do it again, Andrew. Oh, you did quote. You did. You can't do that. You got to spell it right. I was like, Mubot, wake up. I hope I do well on this stuff. Yeah, it's a little bit confusing. Lots of practice. Try writing questions. I might stream even later tonight. You never know. Charlie, ridiculous. I love all these. I love seeing all the points. Love everyone's been working super hard. I'll be on here definitely tomorrow. I'm gonna send out announcements. Among Us. I know we need to do it. And I got an opening for Tyler on the way. We got a bunch of stuff. But for now, we will get some Among Us. Will this Yep, Griffin. It'll be posted. Once I end the video, it posts. If you want to put timestamps in the video, that is a huge help for me. I'll probably come back and put in timestamps. But if you're watching something and you just want to put like blah, 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 blah time, I put that right in the video right away when people post timestamps. And then we can put the descriptions on there. But I tried to make this video pretty organized so we could go through the steps. And yeah, I think that's got it. Any other last questions before we head off right here? We went through the different types of tests and we went through the formula sheet, which is a really good help, I think, right here. So it was a really good review of the different tests we're using and why. And then we did the formula sheets. We went like through each one on the formula sheet and did examples for each one. So really good kind of review of the concepts and when to use them. I don't think so. You're welcome. Awesome. We'll be doing more reviews. We'll be doing more reviews, at least tomorrow, maybe tonight. You never know. You never know. So great job, everybody. Email me questions. Don't question. 201. Exam 3 is chapter 13 it is sampling distribution of, so let's we'll go grab the topic sheet. It's sampling distribution of the sample mean. So that's UT final exam policy. And here we go. Tools. Here we go. Topics. Here we are with the topics. There we go. Why you do that? There we go. There we go. Let me see something real quick. There's confidence rules for the means. Yeah, I'm pretty sure confidence rules for the sample proportion are not on here. It's on previous test. Tell Terry we need to update the sheet. So we do have sampling distribution on here for the sample mean. That is what we first started with. So sampling distribution, sampling, there it is. Sampling distribution's right here. Sampling distribution of the sample mean. There it is right there. Sampling distribution. And it goes all the way down to the business analytics. And so business analytics is a very small section and tools and techniques. We don't have a ton of questions over those. So do not go through and look over all your notes. Do not be like, I'm going to read every chapter over again. Don't do that. I just discovered, but how do we submit our points? So Griffin, I think you are excellent on points. Griffin, you have more than enough points. You have your 2 points on your final grade. The points were submitted via the Canvas link. But Griffin, you have more than enough points, so you definitely have it. You'll get your 2 points on your final grade. Great job, Griffin. Congratulations. And thank you so much for being here and doing all the work. But the other points that I usually shout out, I submit via that. I'm also mentioned that I'm working on Python scripts, so I can say like give all and then give everyone points. You only needed 5,000 all semester, but then also the other points I shouted out. But I'm going to try to standardize it more next semester to where I can type a command in the chat. My goal is next semester I type give all and I type something like 2, and it gives everyone points, like 50 points for everyone who spoke over the last 2 minutes. So I can be like, hey, like if you're chatting, like, so 2 points on final grade, give all 1 million points. And then I got to make sure the command only works for me, that the bot only responds to me saying give all points, which I think it does. I think it only responds to the owner. No, I mean, because I think we'll do a quick test. Streamlabs bot documentation. Here's chatbot documentation. I'm trying to see how to give points. There's giveaways. I don't have giveaways. Okay, here it is. Okay. So, Andrew. Those commands don't work, Andrew. Let's try this right here. Check your points real quick, Andrew, for me. So go ahead and check your points, Andrew. And then we see there's points added to viewers. Okay, so check your points now. Oh! It did work, I think. It did work. Wow. Okay. And then, Andrew, I want you to check this again. Let me try again right here. And then let me try. So these commands are already here. I just need to look through the commands documentation. Okay, so check again. It seems to be working because MuBot's talking to me. So you showed the points back now. Do this, Andrew. Copy what I wrote, Andrew, and I want you to write, just copy exactly what I wrote. The exclamation point mark points, add Andrew Wind, 10,000 points. I want you to just copy paste that into the chat and see if MuBot replies to you. I think I can just do it this way. Wow, why don't I just look through documentation instead of like trying to get my own code for this? So it looks like, yeah, it doesn't respond to you. Watch this. Let's see if this works. So I think I just gave 100 points to everybody in the chat right there. So it looks like I just need to like better map out my points. And so I just gave 100 points to everybody in the chat. And yep, that gave 100 points. So that gave 100 points to everyone in the chat. And oh, I can't do it. I don't want to do this. Who? I wonder what this will do. Oh, let's try this. Okay, I didn't do it. Check your points again, Andrew, because I might have messed everything up. That was supposed to transfer all your points to Mewtwo. But yeah. Okay, good. I didn't want to transfer them myself because I like seeing my points because it's pretty interesting to see like my totals. But I can give points to active users. I can remove points from active users. I don't want to do that. And what is an active user defined by? But I want to do it if they've like, and you know, yeah, I know I want to make this even better next semester. So like, where's an active? That way you'll know if the user is active in case chat is moving quickly. Like, what does it mean if they're active? Like, I was trying to rewind the live stream. Have you covered what chapters are on the... Yep, we were talking about that right now. It goes all the way from chapter 14, starting with sampling distribution of the sample mean, and goes all the way down to the business analytics. So this is we could do this maybe tonight, tomorrow, or something. Hey, Brian, did not know you were doing this. Oh, yeah, no, we went through a lot of topics. I'm probably going to head off here in just a second because we've got about 2 hours, but just wanted to hop on, do some review. We went through the whole formula sheet. Shakira, thank you so much, and everyone for swinging by. Went through the formula sheet, and yeah, and we'll probably do this maybe same time tomorrow or something. Just hop on, do some review, but we got a lot of good things today on here. We got a lot of good stuff on this video. And then we were kind of messing around with MewBot right here, trying to make MewBot work even better. You can only test MewBot on live streams. Where's that documentation here? I'll put it in the chat. The documentation for MewBot. That's right. I think that's right. Here's what I Google. It's the top link if you Google this. Don't be scared. Don't be scared. Google that, Charlie. It should be the top link. It should be... I think I can put in the chat. Yes, it's fine. So here it is right here. That should go to it, right? Oh, this documentation? Good question right there. I thought you were wondering about MewBot. I was like, oh, this is how you program MewBot. So let me remove that. I don't want people being like, hey, I got to go to that link right there. That's MewBot documentation. This sheet is located... I always missed the screen by an inch. This screen is located right here. There we go. And so that is where all that is located right there. That's everything. Great job on all the points, Dan. Excellent work. And so this is where we have all the video links. So you can see all the great review videos right here. Check them out. Especially I would start right here on doing the testing. You can see Brian Inception. This is me 1 year ago. This is 1 year. 1 year. 1 year. 1 year ago. Should go put on that same shirt. I did the conditions, right? I thought I made a conditions video. Did I do the conditions? We did conditions here earlier. There's the 4 steps. That's got it. We're trying to figure out once the world, stops catching on fire, once the world's no longer on fire. Why am I? Look so out of it right there. What happened to me? Happened to me is I didn't get a haircut. Once the world's no longer on fire, then we will have a wedding. Gotta stream it for Stat Nation. Oh, that'd be really fun. I don't know if Chelsea. That'd be pretty crazy. Oh my god. Well, I'm gonna end the video. So that way I think we hit the 2 hour mark, so I gotta watch out because then the video takes more time to upload. But that's got it. I'll be back. I'll talk to everyone later. Bye, Andrew. Bye, Charlie. Bye, Dan. Bye, Rocky Top. Bye, Shakira. Bye, anyone else who's still in the stream. See everybody later. Bye for now. Bye. Let me hit my cool outro screen. Cool.